Were you guys in a class before this? I don't see everybody here.
Good morning.
Okay.
Morning.
Morning. Give me 1 second, guys. I will just send the link to the package group. Okay, guys. So I apologize. I didn't have classes with you guys yesterday. I was not feeling well. I'm still not feeling well today. My throat is hurting. So if my voice goes in a few moments, then it's because of that. Um, we are continuing with the unit of shaping our faith in God 2. This is our second unit on geometry. And this week is a little bit easy, I would say, because it's just angles. If you guys had taken a look at the content that I have posted. So today I'm just going to be doing an introduction of the information. So, my deep hope for this unit is that we may be God worshippers and image reflectors as we nurture our faith through courageously designing. And this is what we have been doing with our construction, courageously designing these things because we are using our hands to create these things. And even our flyers that we have been doing, a graphing that we have been doing for the past 2 weeks, all of these contribute to our idea of courageously designing. And this week, that idea continues, right? So now in our framework, when it talks about creation, fall, redemption, restoration, we're gonna continue with fall this week, and hopefully, as we look at the content throughout the rest of this week, you guys will be able to understand that we are no longer practicing our creation responsibility. It's something that we don't feel that responsibility that we have to do it. It's something that we are basically ignoring at times. Like, do we feel the need to take care of creation? Do I feel like I, as a human being, as a child of God, I have this responsibility to do? And I'm pretty sure that in most cases we don't feel that way. Even I include myself. I don't feel that I am doing my best at this creation responsibility that God has given to us as human beings. And through the activities for this week, now this is what we want to be able to understand. And our essential questions when we're talking about geometric properties and using the geometry, all of these geometric concepts that we have been doing, how can I use this in the real world? Last week, I'm pretty sure that all of you, when you were doing your constructions, and I have returned all of those and I have graded all of those, you guys can go ahead and see your grade. But when you're I'm pretty sure that a lot of you didn't know how to use your math set completely. 100%. Did you know everything that your math set bring has a purpose, a specific purpose? Did you know that you could make angles 30 degrees, 45 degrees, 60 degrees, 90 degrees without using the protractor? So, how am I going to be using those concepts now in the real world? What does my math set? How does knowing how to make those angles help me in my real world? Or does it help me? Or will I ever use it? I love these things, right? And that is what we want to understand and to be able to answer at the end of this unit. Now, this week we're gonna be talking about angles. We're gonna be talking about parallel, intersecting, perpendicular, skew angles. I don't have it there, but skew angles as well. I just want you guys to understand What are the difference between these four things? And also, after we have parallel, intersecting, perpendicular, we have these lines. What are the angles that these lines form? And this is what we're targeting this week. So today's class, today is November 16. We're going to be doing one exit ticket, and the exit ticket is in the chat. I want everybody to do this. Name me two tools that you remember that are found in your math set. Any two of them. Everybody. So I have 27 persons. I'm supposed to be 27 answers in the chat. Name two of the tools that are found in your math set.
You're on the chat, mister.
Yes, in the chat. Okay, good. So let's see the answers. I have ruler, compass, pencil, compass, and scales. Very good, Jamar. Using the word scale for a straight edge or a ruler. Very good. Compass and ruler, compass and scales. Very good. Using the words compass and razor, compass and a straight edge, compass and a divisor, compass and ruler, protractor and the straight edge, pencil and compass. The ruler and the scale are the same thing, right? There's a ruler, scale, straight edge. All of those three words mean the same thing. Straight edge and divider. Very good. The divider. We didn't use the divider, but divider is in your math set. Divider is in protractor, compass, ruler, compass, pencil, straight edge. Very good, guys. Thank you for sharing your responses. Now, we're going to begin with the types of lines today, and we're going to talk about these four lines: parallel, intersecting, perpendicular, and skewed. So first, we're going to be looking at intersecting lines. And intersecting lines are two lines. All of these are two lines. So we have to talk about, when you hear the word pair, you're talking about two of them. Now, when we think about intersecting lines, intersecting means that they cross each other. But when they cross each other, they make acute and obtuse angles. And that is the keyword: acute and obtuse angle. Now, why? Because if I take a look at where Q is positioned, angle Q will be what kind of angle? Acute or obtuse?
Obtuse.
Obtuse, very good. And now if we take a look at the bottom angle, it will also be obtuse. Now, the left angle and the right angle, what angles would those be?
Acute.
Acute, very good. So when we have intersecting lines, these lines could cross whichever way. It doesn't really matter. Once they cross each other and they form obtuse and acute angles. Now, looking at perpendicular lines. Perpendicular lines are also two lines that cross each other, but when they cross each other, they make perfect 90 degrees angles. And this was our construction, one of our constructions from last week, where I showed you guys different ways of constructing a perpendicular line. Perpendicular lines. And you guys were able to do that using your mathematical instruments and your tools. So, perpendicular line and intersecting line, both of them cross each other. They form like an X shape, but the perpendicular line forms a 90-degree angle, and an intersecting line forms obtuse and acute angles. Parallel lines. Parallel lines are two lines that never meet. And why do they never meet? Because even though they are running in the same direction, the distance between these two parallel lines is exactly the same. So even if one is going more longer than the other one, or if they keep extending on whichever way, whichever end of the line, these two lines are never going to meet because they're the same distance. So they can continue extending and extending and extending, and they're never going to be meeting. And then last, we have skew lines. Now, skew lines are not parallel, they're not intersecting, they're not perpendicular. These two are on what we call non-coplanar lines. They are on two different levels. And this is more when we do geometric constructions, and when you do deeper geometry, then we go ahead and learn more about skew lines. But if we take a look at these lines, they do not run in the same direction. They are on two different planes, and there is an angle that is formed between these two planes of the two lines that are on these two planes. But now when we look at skew lines, we're not going to be concentrating on skew lines because this is for a little bit more higher level math, that we will be looking at angles of skew lines, constructing skew lines, and all of these ideas. But these are the four lines that we have to look at and we have to understand: parallel, intersecting, perpendicular, and skewed lines. But parallel, intersecting, and perpendicular are the ones that we will be looking at when it comes to angles formed by pairs of lines. And now these are the ones that we have to know so that we are able to do the assignments for this week. The first theorem is what we call the vertical angle theorem. Now, what does this look like? If we look at that diagram, what kind of lines are these? Out of the ones that we just saw.
Intersecting.
Intersecting, very good, intersecting. Now, vertical angle theorem is very, very easy to understand. Now, this theorem, and I don't have to read what is there, this theorem basically says that whatever angle is at the top, that angle is also going to be at the bottom. Whatever angle is on the left, it is also going to be on the right. So that's why you see a double angle at the top and at the bottom, because if the angle at the top is 150, the angle at the bottom will also be 150. The angle on the left, if the angle on the left was 30 degrees, the angle on the right is also going to be 30 degrees. All right? Everybody has this clear? Can I move on?
Yes, ma'am.
We're going to be practicing this at the end, right? When I cover all of these theorems, we're going to do a practice activity so you guys see how the calculation applies, right? Now these ones. Corresponding alternate and interior angles, sorry. So these are three different angles: corresponding, alternate, and interior angles. All of these are formed by a transverse cutting into a parallel line. If you take a look at each of the diagrams, these lines that run across are parallel lines, and the line that cuts through them are what we call transversal lines. Transverse lines. So a parallel line, these are the ones that are formed by parallel lines. If you take a look at the previous one, this was intersecting lines. These ones are parallel lines. And each one of these, one moment, guys. Okay. And then each one of these has their own rule to them. If we look at corresponding angles, now what does corresponding mean? Corresponding means that if this is 50, this is also going to be 15. They correspond to each other, they're the same thing. So now taking a look at the diagram and how this is labeled, if angle A is here and angle A is 6 degrees, angle B that is in the same position as the other line, see they're in the same place but on different lines, this is also going to be 60 degrees, and both of these are equal to each other. When we look at alternate lines is what we call the Z theorem because it looks like a Z. A Z is formed right here. And if angle A is 50 degrees, then angle B is also going to be 50 degrees. They are equal, and both of them are in the closed section of the Z that is formed. And then now we have interior angles, where interior angles are formed by like a C shape. It's boxed in. And what happens here now is that if A is 100 degrees, B has to be 80 degrees because both of these, when I add both of these, then they have to give me 180 degrees. Any questions with these three? Do I need to repeat them?
Makes all interior angles have to add up to 180 degrees.
Yes. So if even if this is on the other side, this angle over here and this angle over here have to add up to 180. This is what we call the interior, always, all the time. That's the rule. Yes? Clear?
Hear me.
Okay, good. So let's see now. And then now we have adjacent angles. And adjacent angle is basically just identifying them. Adjacent angles are like when you remember when we did sine, cosine, tangent, when we did trigonometry and there was the adjacent side and you had to label your triangle. What does adjacent mean? If I had theta, where was the adjacent of the theta? Anybody remembers?
Miss, it was the opposite. It was it was the other one. It will never be like in the same position as the opposite, I think.
Okay. So we have our triangle, right? We have our triangle. We know the opposite and we know the hypotenuse, but where was the adjacent? If I had theta, where would the adjacent be? Like across it, or where would it always be?
At the bottom is it?
But wouldn't it be beside the theta? If it was either at the top or at the bottom, wherever it was, wasn't it always beside the theta?
Yes.
Okay, so adjacent basically means beside it. And now when we talk about adjacent angles, using the same word, but now adjacent angles are just two angles that are together. And when we have these angles, there is one arm that connects both of these angles. And then you guys can look at these examples that are here. When you have two angles that share one side, this is what we call adjacent, these ones. When you have things like this now, these are not adjacent angles. It has to be only two angles that share one side. Yes? Clear? Clear? Can I move on?
Yes, ma'am.
Okay. And now we have same side interior, exterior angles. And this is basically, I put it here on purpose because this is another name for interior angles. When you have interior and exterior angles. And when you take a look at these, I would suggest, I'm not going to be covering this one in detail because once you understand what I explained first, this is just like extra content. But I would suggest, guys, go back to this PowerPoint, look at the angles in detail so that when we talk about the activities tomorrow, you know what I'm talking about when I say interior angles, alternate angles, adjacent angles. You know what I'm talking about. So, we're going to be doing this activity. Let me share the screen right here. You guys can see that. Can you see that it says start?
Yes, ma'am.
Okay, good.
Yes, ma'am.
So, can you see that?
Yes, miss.
Yes.
Okay. Okay, so this is the question. It says, what is the value of the missing angle? The one that has a question mark.
15.
50 degrees, miss.
Why? How did you get 50?
130 degrees by minus 180 degrees, miss.
Why 180 though?
Because it always to be 80 degrees triangle, miss, and a triangle.
But that's not the triangle. See, you have to, if you guys have taken a look at the activities, you have
Miss,
to provide your reason, right? Um, who said who unmuted?
Miss, it's miss because um it everything is 180, but if you plus 130 plus 50 gives you 180.
Okay, I'm not saying I'm okay, that is completely correct, but I want to know why 180. Why couldn't it have been 360 or 240 or 270? Why 180? And you have to tell me why. Where did you get that 180? Remember when we were doing we were calculating for angles in trigonometry and you had to give the reason? You had to provide your reason. Now we're going back to these things. What is the reason for you using 180 degrees?
Miss, because it is a
Miss,
straight
because
line.
it's half a circle, miss. It's a straight angle, miss.
But where are you seeing half a circle? All I see here.
The
The
yellow
yellow
line
line,
is
miss,
on
and
the
the
left
blue line,
side
they're
of the
asking for the blue line, and the yellow line, which it make the circle, miss.
But we don't have a circle and we're not working with circles. All I see here is adjacent angles. I see two angles that are together. One, you have the yellow line and then you have that blue line. That is all I see here. Where are you getting the 180? I know that you know where, but you're not explaining it to me correctly. Where does the 180 come from? What in this picture tells you that there is 180 degrees there?
Miss, the angle?
It's an
Which
angle, miss.
angle? What kind of angle do you see?
Adjacent
An
angle, miss.
obvious angle, I think. Okay.
Yes, it's an adjacent angle, but the adjacent angle, if I go back to the PowerPoint, the adjacent angle does not tell me, okay, an adjacent angle is measure 180 degrees. Nowhere does an adjacent angle say that. All the adjacent angle is two lines that are beside each other. What in this picture tells you that there is something? What in this picture measures 180 degrees? There is an angle there. But
Which is
what
yellow
kind of
line?
angle? What kind of angle measures 180 degrees? What is the yellow line? What do we call the yellow line? What kind of angle is the yellow line? Let me be more specific.
Miss, a straight angle measures 180 degrees.
Very good. A straight angle measures 180 degrees. So we took long to answer this. A straight angle. It's not a straight line. When we're talking about an angle, we want to talk about straight angle. This is a straight angle. A straight angle measures 180 degrees. If I have to, I didn't think that I would have to go over the basic angles, but you have right angle 90 degrees, acute angle less than 90 degrees, obtuse angle more than 90 degrees but less than 180 degrees. A straight angle measures 180 degrees, and you have a reflex angle that measures more than 180 degrees but less than 360 degrees. And these things should be basic knowledge for you guys. You should already know these things. Would you like me to put something in Google Classroom that has the information for these angles? Or add it to the
Yes.
PowerPoint. Yes, write it before I forget it. My to-do list, add info about angles so that you guys can go ahead and remember these things. So let us put the answer for this one. You guys said 50 degrees. Very good. Here, what is the answer?
100, miss.
100. Very good. And with the same reason, it is a straight angle. Right? What is the value of the missing angle? What is the answer in this question?
42, miss.
Why? How did you get 42?
Because it is a right angle, and a right angle measures 90 degrees.
Okay, very good. It is a right angle, and we could see that to the symbol that is given to us there. And we did 90 degrees minus 48 degrees, and that should give you 42 degrees. Next one.
39, miss.
39. Okay, very good. This one.
32, miss.
If you don't have, use your calculator, guys. You don't have to be guessing the answers. Use a calculator. Is this one. What is the answer?
90 degrees, miss.
Look at the question carefully. See where the question mark is? They're asking you for this angle only. Only this angle.
32, miss.
How did you get 32?
By subtracting 56 minus 90, miss, because it is a right angle, and a right angle have a 90 degrees.
What tells you that this is a right angle? Or did you just assume that this is a right angle? Is there something in this diagram that tells you that this is a right angle?
No, miss.
So we can't use 90. I can't say, okay, I know what the person would have in their mind. I'm going to use 90 degrees. I cannot do that. I have to use the information that is given to me in this question. What is given to
Miss,
you? Yes, Jesse.
is it 28?
How did you get 28?
Miss, because that's less than 90 is an acute angle.
Okay, what did you do to get 28? What calculation?
I did 84 minus 56 and it gives me 88. I mean 28.
Very good. If you look at this question, they already tell you this entire angle measures 84 degrees. It's not a 90 degrees angle because there is no symbol that indicates to you that this is a 90-degree angle. They're telling you this is 84 degrees. And they're telling you that this part measures 56. So what is the other part? Well, I do 84 minus 56, and that gives you, let's see, 28. Very good. Okay, here you go. What is the value of the missing angle? And this is the angle theorems, the vertical angle theorem that we covered in the PowerPoint.
35, miss.
35, very good. Next one.
59, miss.
59, very good. This one? Anybody?
33.
33? It's not 33.
It is 123, miss.
Okay, we already got that one wrong. It was one. Repeat again, Jerome.
123.
123. Very good. This last question
Means the answer will be 24.
for this one.
24.
24. Okay, very good.
24.
Okay. Let me can you guys hear me clearly because my internet is really really slow right now. It's loading very slowly.
Yes, miss. We can hear you clearly.
Yes, miss.
Then it's just on my end. Okay. Okay. I stopped sharing but I still see a black box there. I'm not sure. The activities for this week, guys. I'm trying to open it, but it's loading and loading and loading. The activities for this week are, if you have taken a look at them, they're basically like two tables. Um, what I would like you guys to do is that you either have a copy of these with you. You can make a copy of them, an electronic copy, and I think that I made a copy for each one of you. Okay, let me see if I can share it because it's activity one. Hmm. I'm trying to share it, but it's not sharing. Can you guys see a document?
No, miss.
No, miss.
No, miss.
And here it says I'm sharing screen. It's my internet. It's taking forever. Okay. Okay, but looking at activity number one, it should load at some point. But if you guys have taken a look at it, um, it's a table. It has a diagram of a cube on it, and that cube has so many lines all over it. These lines that are there represent the angles that we have been talking about and different types of lines that we have been talking about. So activity one, let me see if I can share again. Okay, now can you see it?
Yes, miss. Yes, miss.
Okay.
Yes,
Yes,
miss.
miss.
Okay, good. So this is the first activity. If you guys have your package and you guys are able to see this, then if you're online, then I have it there for you. Now this cube has so many lines. Yeah, I could say line AP, line AX, line AG, line AF, line AH, all of these, so many lines that this has. And this table now gives me these pairs of angles. So I have to look for line AB and I have to look for line FG. AB and FG. See, A run to B and F runs to G. And I have to check, are these parallel lines, perpendicular lines, skewed lines, intersecting lines? And I have to check, I have to see which one of them does AB and FG represent. And the letter that I choose, and that is the letter that I'm going to be writing on number one, number two, number three. And at the end, it should give you the answer to the right here, to reveal the mathematician who developed hyperbolic geometry. And that is what we're going to be doing for all of these. So um I would have to check. I will be posting it later on in the Google Classroom because it's mostly for those of you that are in Google Classroom. If you would have to draw the table, if you can print it out, that's very good on your side. Or if I will see if I can give you a copy to each one of you so everybody just highlights your answers as we go along tomorrow. I think that would be easier for everybody, right? Instead of drawing the table. Yes?
Yes,
Okay.
miss.
Yes, miss.
So that is what I will be doing. So if you see me delete it and repost it, it's because that is what I'm doing. I don't remember if I did it for both assignments, but I'm sure that I did it for the second one. And then the second activity. So this first activity, this is all that we're gonna be doing tomorrow because this is gonna take us some time to do. And then on Thursday, we're gonna be doing activity number 2. But the good thing is that as we finish number 1, activity number 1, because you guys will be working on the document, then when we are finished class tomorrow, everybody can just send it tomorrow because everybody will be putting in their answers. Yes? And activity number 2 is this one. And this is the one that we will be working on Thursday because this one is more calculation. And if you take a look at this one, you have to give me the magnitude of the angle, how much does the angle measure, and then the reason for that. And then also it has an icebreaker at the bottom. So this is the one that we're doing on Thursday. Everybody clear with that?
Clear.
Yes, miss. Yes, miss.
Very
Yes, miss.
good. So we are finished for today's class, guys. Anybody has any questions before you leave?
Uh,
No questions?
no, miss.
So be prepared for tomorrow's class and Thursday's class. Package group, if you're joining Wednesday and Thursday, make sure that you have your package with you so you are writing as we are working it. And then those of you online, make sure that you have the document open with you so that as we are working it, you are also working on your document. Yes? So that is our plan for tomorrow and
Yes,
Thursday. Have a great rest of day, guys, and I will see you guys tomorrow for class.
Bye, miss.
Bye.
bye, miss.
Bye, guys. Bye.